When we talk about carbon in buildings, most people immediately think about energy used during operations, such as HVAC, lighting, plug loads. That's only one part of the story. What is often missed, in this is the significant portion of the building's footprint is already locked in even before the building is occupied. That is the embodied carbon. 70% of the lifetime of the carbon, can be determined even before the day one through the design and the material choices. Why this matters to us as developers, as engineers, contractors, suppliers, and as governments and regulatory bodies, all of us are now bothered about it at one level or the other. And carbon doesn't sit in one place. It is distributed across material systems, construction processes, and operation. Understanding where carbon actually lives in a building is the first step towards managing it. Without this clarity, we may end up in optimizing the wrong things, or it may not be effective. So it could be an invisible challenge with embodied carbon particularly. So two materials can look identical, they could perform identically, they could even cost the same, yet they may have radical carbon footprint. Without the carbon data, construction teams and as well as the project teams, including the client as well, may not have the way to distinguish between them, and the high carbon choices may get locked in the project unintentionally. So we have to break down the embodied carbon on a clear pattern. And around 80 to 90% of the embodied carbon in a typical commercial conventional building comes from these five materials, understanding from the research and from the larger data, that is concrete, steel, aluminum, glass, and facades. So let us catch something important. We don't need to manage everything equally because it's highly impossible to do that immediately. We may need to focus on the few materials that matter the most. So once we understand where carbon is coming from, then the next question can be, how do we measure it? How do we compare the alternatives? And how do we make informed choices? So that's where, of course, architects have to start with design. The net zero, the design intent has to be logged in. So we may need to start with the basic, with respect to passive architecture, envelope design, efficient design. And once we have done that, then we may need to move towards the system side, the most efficient system, not start the other way. So we have to build the pyramid from the foundation. And the material choice is directly defining the embodied carbon, so that has to be done as well. So to support this, the most important part of my talk today, we may need to come up with tools which could help us to understand about the carbon data. So there are a lot of tools available in the market. One-click LCA, EC3, most such tools are available. These tools are underpinned by international standards such as ISO 14040 and 14044 and so on. So they ensure consistency, transparency, and comparability. Let me tell you how do they work. This process is called carbon modeling. So carbon modeling is essentially a scenario-based process. It starts by defining the building scope, systems, materials, and quantities at a given design stage. And of course, emission factors can be applied using the EPD, environmental product declarations, or generic data sets. What makes carbon modeling powerful is the comparison. So we may need to compare, one scenario with the other. So even if at all we make an, 25 to 30% of difference by altering some material choices with respect to the EPD data, if possible with respect to the specific vendor specific data, if not at least with respect to generic data sets and EPD of the international standards, we could understand how much carbon that building could be, consuming when it comes to embodied carbon. Then we may move towards the next stage. So that is the next stage where we would like to, do the transition. So measurement alone of, measurement of the embodied carbon alone doesn't reduce the actual carbon. The real impact happens when the modeling outputs are translated into action. So this is where the carbon targets move from spreadsheets into specifications, we can call. That is the tenders, contracts, where they can actually influence what gets built. So construction is where net zero intent is tested when it comes to the reality. So carbon targets must be embedded into procurements and BOQs. So materials delivered on site needs to be verified against the EPDs, whether the contractor is procuring the same. So the on site teams can verify that, and we can do, it's recommended to do audits on site. And most importantly, the project must capture as-built carbon data, replacing assumptions. We need to adhere with the assumptions being made with respect to the construction stages. Ultimately, net zero is proven in operation, so we may need to consistently keep a track of record of the energy, water, waste, along with the overall CO2e data that could be called as scope 1, scope 2, and scope 3, the direct and indirect emissions. And renewable energy can also be brought into the equation, and they can be generated or procured by power purchase agreements or anything of that sort. And net zero is not just an one-time achievement, it needs to be consistently considered as an operational commitment. So that's the process, and that's where I would like to introduce about Global Network for Zero. We are a net zero certification body, and not just in one phase. We believe that our role is to provide structure, consistency, and credibility to the net zero claims. So as I mentioned, we are a certification body. We work as a network, and we work on the universal standard of GHG protocol. We have a platform to accelerate this. We have an implementation ecosystem to work with our partners and our projects to enable this. So we provide net zero certification for buildings. We have extended to portfolios and also for businesses, for whole of the business operations, which could be buildings and as well as any operations in scope, in scope 3, such as supply chain, logistics and so on. So we don't see net zero in a single metric. Net zero, we see net zero as net zero energy, emissions, water, and waste. Energy focuses on balancing annual energy use with renewables. Of course, after the reduction has been done, so the reduce, reuse, recycle, then we can look at net zero energy. Net zero water looks at consumption and replenishment as well. Net zero waste addresses landfill diversion ultimately. And net zero emission is the ultimate test where we can test the scope 1, scope 2, and scope 3 emissions with removals and offsets, of course, but not predominantly. That's why we're going to call it as net zero, not as carbon neutral. So predominantly we have to reduce, and whatever cannot be offsetted, whatever cannot be dealt with can be offsetted, only the residual emission. So that's net zero certification. And we do this in a phase 1, phase 2, and phase 3, whereas we initiate, implement, and sustain, whereas projects can come to our platform, they can start reporting, they can use the existing data sets we have, with respect to the emission factors. They can implement the strategies with partners. We have Dr. Anshul to speak, and she's a partner with us, and she's been implementing net zero for quite a lot of projects with Global Network for Zero and as well as other rating systems. So with experts like them, we can expect that the projects can implement the net zero plan during the ongoing operations. But if it has been designed already for net zero, then it makes the job all the more easier. Only for the incremental emissions we may need to be bothered upon, and we may need to sustain net zero perpetually. So to conclude, carbonless architecture cannot be just achieved in a single stage. It starts with intent at the design, evidence during the construction, and as well as performance consistently and perpetually during the operations. So if at all we do that, net zero can succeed, and we can contribute our share towards the carbon goal of the country, of the region, and we can contribute towards. We can start contributing with the NDCs to the nationally determined contributors, and ultimately we may move towards a carbonless future. So it's great that we are having these sort of conversations. I believe that this accelerates the mission. So it's been an honor. Thank you. Let's build the future differently and responsibly.